And I also welcome all the HODs, faculty members, and my dear students. Now, I would like to introduce our today's speaker, Dr. Sunil Kumar. He is Director Data Science, Ericsson Global AI Accelerator, Bangalore. Sunil has 16 plus years of industrial and research experience in machine learning, deep learning, analytics, Internet of Things, and automation. Sunil worked in Oracle, Infosys, R&D, and Philips Research before joining Ericsson. Sunil is lead inventor of 25 patents, including 6 US granted and 19 pending applications. He has published 30 plus papers in both international journals and conference and delivered 100 plus guest lectures. He is a senior member of ACM, IEEE, and fellow of IEEE. He is one of the top 10 data scientists in India for 2019, recipient of Zinco Technical Role Model in Emerging Technology Award 2020, and ACM Distinguished Speaker. He is a co-chair of industry engagement in IEEE Bangalore section, recognized thought leaders and speaker in top AI forums. He is an alumnus of IIT UK, IIT Bangalore, and IIM Ahmedabad. Over to you, sir.
Thank you. Thanks for the kind introduction. So you can hear me and you can see the screen, right?
Yes, sir.
Yeah, at any time, if there is any interruption, because we are all connecting from home, right? So please alert me. And if there are any questions also, the participants can feel free to chat, or if it is very important, you can stop me as well. But otherwise, I want to give at least towards the end 10-15 minutes for discussion. Okay, so let's start with this. So what we are going to cover today on the pleasant evening, as I mentioned. So what we have here is essentials and applications of AI. So what I'm trying to cover, because it's a mixed audience, there may be people who are already working in AI and who may be experts, or who may be just introduced to the topic, and there may be some people who are just heard of the topic AI but not much into the data. So everyone can take some key takeaways from the session. So we'll start with very basic, maybe first 10-15 minutes, and what is AI, what are MLDL, the basic terminology kind of thing, even though we can't go deep into that, but at least some common terminology kind of a thing. And then why the hype is now people are talking about, and what kind of concepts are really people are using in the industry. Because before jumping into the application, we should understand what are the different techniques we are using, at least at a high level. Then we'll jump to the next part of the point, where how people are trying to use it, and I'll talk about the applications are also very vast, but at least I'll try to cover some of the applications maybe at a 10,000 feet level, where you can really appreciate, yes, these are all the things which are happening, but we can't stop there. We can go to real, as a student or as a researcher, as an aspirant in the data science or AI. So if you want to start also, at least this should help you as a kickstart, or as a motivational talk in the sense of what you can really achieve, right? I will point to some of the references as well, because within 1 hour I can excite the people saying that these are the applications. We can't go too much deep into that. So the last takeaway is some of the project ideas I'm going to leave you with. So all may not be able to connect with all the slides what I'm sharing, and I already shared the deck to the your coordinator. So it's a public information, nothing proprietary as what I'm talking about. So you will receive it. So if you start about even before jumping into what is AI, ML, DL, all that. So I want to make sure you are appreciating on a day-to-day life. We are talking about these AI applications. So it's not like somebody in the lab. These gone are the days where we are talking about some research lab is talking about AI and all. Now I am talking about some applications to you where you are using it in day in and day out. Only thing is you may not have realized that you are talking about it. Okay, so if you are taking, so why this annotation of image data, text data, you will realize in maybe after 3-4 slides, but at least at this stage, don't worry about domain, what type of data, but at least, okay, we are talking about COVID is the thing in 2020, almost we are going into the end of the year. but we'll never forget this year, and then we'll never forget this COVID thing, right? So there's a lot of role AI is playing, be it in the vaccination or classification of chest X-rays, or what you say, the quick identification of the a particular virus. There's a lot of things which AI models are being built. Then you may say that, okay, I'm not used it personally, but think about social media, face recognition, tagging the people in your Facebook or Instagram. So these are the things which are features which are available these days, which are not there in the beginning of the, let's say, be it Facebook a couple of years ago. All of us are using, most of us are maybe using the credit card transactions. At the back end, there is a fraud detection, and you might have received some of the transactions. It's like if they want to make it as a foolproof system, right? But still the fraud is inevitable. So how early you can do it, how can you minimize the retrospective? Within fraction of seconds, we need to do it, those kind of fraud detection. Then building a chatbot. So nowadays, take your favorite website, be it your Make My Trip, or maybe SBI, or ICICI, or any of your banking needs, or your favorite site. You are talking about chatbot, right? Maybe initially we think that there is someone else at the other end who is solving our queries, but most of us know at this stage it's a chatbot which initiate the conversation. Maybe after that, maybe if it's a complex and it's not able to answer, maybe it goes to the human agent. So some of these applications have complete backend at the AI, and then we are using it day in and day out. So I'm starting with applications, going into some of the techniques, and I'll again come back to what is in for you. If you want to really use the AI, what kind of applications you can target. So maybe next 5-10 minutes just on the basics point, so that everybody on the same page. So we are using these terms interchangeably: artificial intelligence, machine learning, deep learning. But ideally, deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. The talk is not just limited to ML and DL. I'm using ML for machine learning, DL for deep learning. So if you see here, I borrowed the slide from Oracle thing. If it shows it's not new, that artificial intelligence is not new. It is goes back to almost like 1950s. And then almost we have seen some kind of a research problem solving almost 50, 60 years ago, including the basic deep learning is 50 years old. But there is a AI winter. There are a lot of hype was there even at that time, but we could not, or maybe the technology did not prove enough maybe 30 years ago. So in 1990s, even though hype was there, the similar to this present scenario, maybe lack of compute power or lack of digital data, and then good use cases to prove that it is confined to only a lab level, experiment level. So it did not really go on to the masses as we are seeing now. Democratization did not happen. So when it comes to the AI, there are a lot of techniques: logic building, knowledge representation, which is not part of ML and DL. But when it comes to the machine learning, it's actually a specific techniques where I will explain what is machine learning, deep learning down the line. I have a few more slides. But some technique, the way of learning, it may be supervised, unsupervised, reinforcement kind of a thing. But a way of learning, just like how you can differentiate with the programs, computer programs versus machine learning, I'll talk in next few minutes. But at this stage, you can understand there are different techniques where the computers are trying to learn, and a specialization in that machine learning using the neural networks or the kind of deep learning. So that's the key takeaway at this stage. Just understanding deep learning is a subset of machine learning, which is further subset of AI. But I'll continue the discussion for a few more slides on the same 3 points. For instance, what is machine learning? We're talking about a simple way of talking about is in case of traditional programming, where we are giving data and a program, be it a Fibonacci series or maybe your favorite factorial or any of the complex program of, let's say, computation of tax or GST. All these things, we are giving you the data and then input data, and then there is a program. It can be as complex as thousands or millions of lines of program. Doesn't matter. You are getting an output. That's a traditional programming using your own favorite language. But whereas machine learning, we are talking about input data, and maybe in some cases we are giving the output. We are trying to identify the patterns out of it, and we are trying to get the model. We can call it as a program, but in more general terms, we are calling it as a model, so that how generic the model can be made. That's the fun part of it. Just building the basic model is not a challenge, but can it really sustain the real data distribution of it is the real challenge for us in the real world. When it comes to the same methodology of machine learning, even though there are so many terms coming these days, online learning, adaptive learning, all that, but at least the basic building blocks point of it, it's more like supervised learning, unsupervised, and reinforcement. What does that mean is, in a simple words, even though some of the terms, I'm sure if you're new to the field, you will be bombarded with these terminology, don't worry on this. But other people who are in touch, at least they will be able to understand all the CNN, LSTM. So here what we need to understand is the machine learning aspects. In case of supervised, I'm trying to help you with the label data. What does that mean is, I'm showing a car and then attaching the name also, the label also to that as a car. So that's the kind of example and how you identify the patterns with that. Unsupervised, we are trying to identify the patterns, but still there is no label attached to it. Maybe based on the properties of those points, you can divide it into multiple clusters, kind of a thing is the unsupervised learning. In case of supervised learning, we do have a classification and regression kind of example. So in simple words, classification is okay. If I give a couple of images of a bike and car, maybe we need to classify either a image, if a new image comes, whether it is a bike or car. Whereas in regression, we are talking about I given it's kind of a prediction as a number. So I give the let's say your grades for last 5-6 semesters. Can I predict what could be your grade for the next sem? So if the same performance is continued. Okay, so those are the kind of examples from the classification and regression. But I will introduce these terms like CNN, RNN in a little later. Don't worry at this stage. So whereas unsupervised learning, as I mentioned, we may not have a labeled kind of a thing, but still based on the properties of the data, I can cluster, I can group different ways. And the new way of learning, in some cases, I may not have, say unsupervised, that means you have data, but you don't have any labels. Maybe people think of unsupervised. Or if you have labels, let me use it as a supervised. But there is another way of looking it into reinforcement. It's not really dependent on the labels part of it. It's kind of a, let's say, a robot path planning type. So you need to take the step at or a decision at each and every step, right? So it's not really a series of data points with a label or without label. That's not the case. So in those kind of scenarios, we need to think of some kind of reinforcement learning, or people give the analogy of just like how the kids learn how to crawl. So they may take each baby step and then maybe they hit the wall, then the pain will come, and then, or maybe parents shouting saying that, okay, that is not the way to crawl, then they will take the turn. So at each and every step, we need some assistance or reward and penalty mechanism. That's what you will see from the reinforcement. So each of the subject is maybe a one semester kind of worth. So I'm just giving you different, maybe leaving you with at a high level view that what these different problem categories are, or maybe different methodologies are. So I already given examples, but let me just see if I have missed out anything in terms of one more is semi-supervised. I talked about supervised, unsupervised, and then reinforcement thing. The self-driving car or autonomous car is one of the examples, or robot path planning is another example. Semi-supervised means maybe you have 1 million data set, but there you are talking about maybe I have labels for only 1,000. Okay, that means it's a kind of a mix, right? So you have some supervised, you have some unsupervised. It's not really supervised, unsupervised, but maybe starting with a semi-supervised. These are also really interesting problems in the real world, because you do have only labels for some data points, but not for all. Maybe you need to go in a take the small data set with the sampling, and then take the input, build the thing, and then test it for the rest of the data. And then like that, you increase your test space, maybe the space, or maybe the initial data set itself. So in a step by step, that's what the semi-supervised will talk about. So what all, even though we are talking about these introductory points, then if you go deep dive into that, what changed in the at least the last 10 years, I'll tell you, because in even though I have 16 years of experience, maybe I am early bird into the AI from past maybe 2011, 12 and time onwards. So that time also, believe me, this much hype was not expected. Okay, in the industry. So because we are seeing every 2 years some technology keep coming. When I was in the beginning of the career, we are talking about Internet of Things. After that, big data, Hadoop. Every 2 years some technology will come, and only few will sustain to the, maybe now blockchain, people are talking about cybersecurity. Some of them are evergreen like cybersecurity, but some of them the hype will come for some time. It may sustain or it may go back. So especially for AI point of it, what really proved is whatever these things we have given already the references, or you can just Google what is ImageNet challenge. What is the challenge special about is we have millions of images, and it is like a public, one of the biggest public source data, which is labeled data. And every year, the best of the brains in the world will compete. It's just a simple classification kind of a problem. Maybe 1,000 categories. What those 1,000 categories are? Simple, like a laptop, a mobile, or bike, a car. These day-to-day objects what you see, and it's actually crowdsourced from multiple people. So why we are talking about this challenge specially is, if you see here, the winner in 2022 in that particular ImageNet challenge, who used deep learning, which may be like a 15 years old by the time, the design wise, which was given by Ian Lucan, he is able to beat, he's actually Jeffrey Hinton student Alex. His full surname is Krzyzewski. Then the other all top minds in the world, they are still using the machine learning approach of solving, where this gentleman tried to solve for the first time on the practical problem using that simple CNN 8-layer network, able to outperform at least with 10% margin. So that's where the people started thinking, okay, deep learning can solve the real problems. Otherwise, the theory is there, and maybe even all the back propagation, CNN, all the things what people are talking about are, and it exists before even 2012. But they are into a specialized small problems it is solving in the research, but not come to the masses or democratized. That's what the main thing it happened. And if you ask really what is difference between the machine learning and deep learning, right? So there are multiple ways to tell it, but in one line, if someone asks, in just like this picture, in the deep learning, we are not expecting any handcrafting of the feature. What does that mean is, in a particular domain, take a car example as a simple one, or maybe your own specialized domain of a healthcare image, you need to extract out the features from there and then apply whether it's your classification or regression. Whereas in the deep learning, you are talking about, you can do it maybe just like a black box, but we are trying to open up the black box as well, what's really happening in the deep learning. So what really means is, even though the compute power and then availability of digital data, all these are the fueling factors for the penetration of this deep learning. In simple words, we are talking about feature engineering also, or feature extraction also can be taken care at the DL, but at what cost? If it is everything is green for the deep learning, maybe people can say that machine learning is outdated and deep learning is the new mantra. No, we are not talking that. It exists, both of them coexist. And the main reason is for that is deep learning demands a lot of, because it needs to do the feature extraction by itself. So you need to do actually the real, or maybe the challenge is here. So maybe for 100 images also, you can by applying feature extraction, you can solve the problem using machine learning. But by the same problem, maybe I may demand you, let's say, 1,000 images. Okay, just for an illustration. So we need more data at that. But another advantage is, if you give more data and more data distribution, if you add, then you can increase the accuracy. There is no limit compared to the machine learning aspects, right? So these are the main differences between the machine learning and deep learning. And once you understand, yes, there are a lot of techniques in the, let's say, once you are enrolling into the course of machine learning or deep learning, either online or through your institute, you will learn a lot of these techniques, what is supervised, unsupervised, reinforcement learn. But in the real world, when you try to apply to the applications, there is some gap. What does that mean is, you do have a lot of these different type. We need to apply in the day-to-day life on various types of data. If I ask you a question, the machine learning or deep learning, let's say take a classification example of machine learning. Is it really dependent on what type of data it uses? Or I can use, let's say, take about, if you are coming from this background, maybe take a KNN or a decision tree, or if you're not coming from the background, I don't want to bombard you with those names. Some machine learning algorithm you have on the classification. Can I apply on any data like this, what I'm showing, whether it's a numerical data, categorical, text and all? Or do I need to just reserve, okay, it's applicable only for images, or it is applicable for only for numerical? Any thoughts, if you are allowed to chat? Am I making sense? Any data. Yeah, some of you are, once it is, yeah, any data. Rishit is mentioning. Yes. So what does that mean is, in the real world, I need to apply any data, but at the same time, then there lies the challenge, right? So when we have different types of data in the real world, when I can apply the machine learning on this, it's not like a magic. I can give directly the text data or image data or video data to the Python program, right? Somebody needs to take care what Python program understands. Let's say I'm not asking about, let's say people will generally jump and say that, okay, computer understands only zeros and ones. That's true. But at a Python program level, when you see that somebody needs to convert into some kind of arrays or matrices where the Python program understands. So be it numerical, categorical, that means it may be center data, metrics or tickets, manuals, alerts, errors, any of these, or videos. I give an example of a healthcare background because that may be the buzzwords these days, with due respect to the other domains as well. You take example of blood reports in numerical, or medical test results, positive, COVID positive or negative, text medical reports or image x-ray or video CT, MRI, all that. Then speech, some conversations. So it can be general, one can be signals, which is not part of any of them. So this is my style of doing this 7 type. There's nothing like a standard way. People may say structured, unstructured, then continuous, discontinuous. There are multiple ways of doing it. But my style of doing this into these 7 forms is simple. Once you understand the algorithm, learning is one part. Second thing, to apply really, you need to understand the data is maybe heterogeneous or homogeneous. It belongs to one of them. Okay. Then it is our duty as a data scientist or as an engineer to convert them into understandable form. So take image, then okay, take the pixel values and convert it into arrays. Or text, you convert it into some kind of a word embedding. There are standard techniques for the pre-processing. That's what one of the key takeaway in this particular session. When you are trying to really talk about the applications, you need to understand, one is understanding the basic algorithm. Second thing is what kind of pre-processing I need to do, because in case of text, I need to do NLP, natural language processing. I need to specialize maybe on that. Then in case of images and videos, I may need to specialize on computer vision. In case of audio and signals, maybe some signal processing I need to specialize. That will help us to understand the domain and understand those techniques much more deeply, so that we can build industry scale or industry grade applications. But if you ask how you want to learn our next set of essentials, or really, can we solve all the problems with the feed-forward networks? Feed-forward network is a simple deep learning things, right? So as of now, I talked about only machine learning and then simple deep learning. But simple deep learning means there is a maybe some kind of if you just type deep learning or ANN in Google, you will get some kind of a series of nodes and connect it to them. That's called fully connected networks or feed-forward networks. But the way of learning, just like I mentioned, in case of numerical and categorical, it may work. But for as you go to the complex things, something like images and videos, you can use some this traditional feed-forward network, but it will be very complex to use them because of the native. Take simple example of an image which you take it in your let's say your friend shared it in a WhatsApp, your classmate or maybe class group photo. Think how many pixels are there. Even if it's in a WhatsApp image, it may be thousands of pixels are embedded into that to convey that information. That means you need to have thousands of these input layers, and then followed by maybe hundreds of other, maybe tens of layers, each of them having hundreds of nodes. It will be too complex. So there may be some special operation like convolutional networks, which is inspired by convolutional operation. Simple. There is some kind of a spatial and temporal correlation in simple methods. So we want to exploit the temporal or maybe especially the spatial correlation kind of aspects using the convolutional network. That means each neighboring pixel is carrying some information, related information. Whereas recurrent networks means if it is a time series kind of a data, then you may need to think it's not just independently a value I'm trying to make a decision, but I need to have a tail of information. Okay, so what I mean by that is, even though I'm not giving too many details of what is CNN, what is recurrent networks, just I want to excite you before learning any new concept like CNN. You should question yourself why I need to understand. Okay, people may remember, okay, for images CNN. No, that's not the way it will work. Even I use the CNN for text data, or we use the CNN even for the these structured data in a time dimension. So what you need to really understand is, whenever there is a spatial correlation in the data, image is a starting example or video is a starting example, you can use convolution. So before you learn any new concept, you started with maybe machine learning. You understand what is supervised, unsupervised, and all that. Then you started with deep learning. Why deep learning? We are trying to understand those questions. If you understand that way, then it will be really useful for the application point of view. I'm not talking from your exam point of view. Those I'm sure you are all bright students and researchers. You can clear those. But when you come to the real one, because what it comes in the real world is nobody will pinpoint and tell you, okay, use CNN here or use RNN here. You need to really think where it will be used, not just by harding. Okay, maybe images, just like this images, if I use, maybe convolutional is a good one. This is how the learning is happening. I can tell it as a car. Okay, or maybe in the images, you have a lot of the transfer learning in the image net. As I started with, you have a lot of these LXNet, which I shown it to you, but that is one of the old one, maybe 2012. Even that we are calling it as old. And you see in the recent years, there are a lot of networks. If you are not able to understand what these are, don't worry on that. My intention there is there are so many pre-trained models in the deep learning, which you can use for your own application. Let's say they are trained on the general images. Maybe you are trying to solve a problem on image, not on the image net, let's say on your COVID-19 chest x-rays, or maybe you are coming from manufacturing domain, you have your own images. So you can apply, you can retrain those. That's called transfer learning kind of a techniques. Then you should be aware of in the computer vision, these are so many methods are available, which are interesting too. We don't require to start from scratch, let me put that way. Similarly, once I learned the CNN, why should I again learn the recurrence? Most of the networks, whether it is a CNN or the regular feed forward network, there is no recurrent thing. And whatever the information you are talking about, I'm making a decision with that information. I'm not talking about any maybe recurrent in the network or maybe any of the historical time series data. But think of the examples like chatbots or stock prediction or speech recognition, weather prediction. Any of these is not just only one or 2 points. If I give you or I bombard you 10 or 100 points, it will not help you, right? You will ask what is the sequence. Based on that, you will predict, even though it's a difficult problems, but at least based on that, you will maintain that conversation. Otherwise, in the music composition, it will become noise. You won't call it as a music unless there is a sequence of rhythmic movements, right? So that's where you require maybe not a CNN, may not be a regular one. You require some kind of a RNN, okay, or recurrent networks, maybe something like LSTM. There are other varieties of that. So if you learn those things, which are the foundation steps for us to really appreciate with the applications, if you go further, let me share 2 points, two thoughts from my side, where once we are talking about applications, with my maybe experience of solving hundreds of these problems in the AI in last 8-9 years. So there are two things. One is maybe from your side, business can be replaced with a research problem. I have an interesting research problem, but not sure what data help me to solve it. Another way to look at is I am sitting on pile of data, maybe something I downloaded from open source, but what research problems it can solve or what business problem it can solve. So even in the industry, we have both the approaches. I'm not saying one is superior to the other, but both of them are really important, or maybe it can start from anywhere, but important aspect is both business problem or business you can replace with the research if you're coming from academic. Both the problem statement and the data, relevant data, are important. That's the key point. Then in the industry, I worked in both services and product industry. So we are not really talking about products and services here, especially in the AI or data science world. We are talking about really platforms and solutions. What does that mean is everybody, be it your favorite Infosys, TCS, IBM kind of a thing, also building platforms, or on the product side, be it Oracle or Google or Facebook or Microsoft, those are also building the platforms, or maybe they are using frameworks or platforms interchangeably. So using that, the solution building is easy. But if you ask me, what is the difference between a platform and a product? A simple way of understanding is product is something like your Oracle or Windows, where it is a monolithic program. It's a composition of a lot of things, but you don't have much to customize there, right? So, but whereas the platforms, maybe something like a Watson, as an example from IBM. So their platform, they are loosely coupled layer components where you can customization or building the solution is easy. Okay, that's the difference. There may be standard. These are the things which I'm trying to oversimplify for you as a students and researchers. You can appreciate, but the standard definitions you can follow later on. You can keep pumping me the questions if you have, so that I will give you the time towards the end, but you can pump in as and when I can pick it up, or maybe towards the end I'll pick it up. So when we are jumping to the applications, let me start with some applications which you can really appreciate, saying, wow, these are the applications which are changing the world. And then slowly we will go into even what is in for me in terms of what we can solve. One such application comes to my mind is autonomous driving. So I'm sure as most of you are talking about, even in India, it is taking a little more time, but autonomous driving, even the fifth level of autonomous driving without any intervention of the human, now experiments are going on, or maybe the approvals pending level, technology wise almost ready, I will say. So, but now the lawmaking should be there, and there are other challenges to come to the live. But if I recollect, maybe around 2011-12 time when I visited the Google campus in Silicon Valley, I remember seeing the track of autonomous driving cars. That time it looks like a science fiction. Even though I have good respect for the Google and all that, when it really come live on the road, and thousands of researchers around the world, and then it is changing the game of typical driving example. Right now, if you visit any time Silicon Valley side, especially the California side, you will see now these days a lot of autonomous vehicles are driving in the test mode now. So they're collecting the data. Maybe Tesla is collecting from their own vehicles, and maybe Google is partnered with other vehicle. Even though people are there and sitting and all, but it literally trying to collect the real data. Maybe anytime soon we can see the autonomous driving permissions. So that application involves a lot of CNN, and CNN. Why CNN? Because it requires a 360-degree cameras to see what's happening in this one, and a lot of sensor data, taking it up, making the decision making. It's a wonderful example of a lot of these deep learning and machine learning applications into that. Then if you go further into the second case, that is maybe a computer vision example picked up. So if you see the NLP, a natural language processing example, if you pick it up, so what comes to my mind is chatbot. So I already talked about chatbot as an example, and towards the end also I will talk. Building a simple chatbot, I'll say it can be one-day assignment for you these days, okay? Because the open source frameworks are there, something like RASA, RASA. I'm just one example which I made my hands dirty, but there are so many other frameworks which are giving you or enlightening us in terms of, yes, it is possible really to build the basic chatbot thing. But maybe if you are talking about industry grade to build, it requires its own challenges, training its own data. There are other challenges. I do agree on that. But at least the basic chatbot building is a cakewalk to start with, but that means it is still a simple rule-based kind of a system. But what is really maybe as a research-oriented problems for that is the generative based. That means you need to, for rule-based means you are not really using AI things, right? You need to make a conversation, maybe in a closed domain. That means what? Let's say somebody wants to build a chatbot for a Pizza Hut. I can talk only on the pizzas and then maybe what toppings and what order. I can't talk anything else. That's okay. Even if you are talking about, you are not expecting a general, maybe there is a Siri, Alexa, which can answer anything, but doesn't mean that that's also kind of a conversation, kind of a bot. But here we are talking about making complete, not just for the fun, but real business problems to solve. I stuck up somewhere in the transaction, it needs to go and help me and take it to the closer. Okay, so there to have the conversational based, it can be generative based. That is a little harder as we speak. And open domain wise, even though it's a retrieval or rule based one, even open domain means I can ask anything. The best examples are Alexa and Siri, as you see. Even there in the open domain, to be generative based, lot of hardest problem now. Okay, people are still working on phases to that. Another interesting point on that, which I will touch upon towards the end as well for a minute or two, or let me cover it here. So multimodal chatbot means generally our mind thinks it is just a text-based kind of a conversation. But why should we stop at text-based? Suppose you are talking about an example of you are building some chatbot to help the admissions process in your, let's say, organization, okay, in your institute. So when you are talking about it, there is a chatbot 24/7 available. You are talking about all the basic information of what is the fees and what is the kind of courses you have, and is it the right course for me? All this you are talking about. And then let's say if they are filling the form, you stuck up somewhere, instead of asking, go to that last and maybe 15th point and all, have a video, and this is how you need to fill it up, and just flash that video. Maybe that may be 10-minute video, but based on the conversation, you know, it is from 8th to 9th minute is the solution what that particular participant needs. So just flash that and play from there. So those are the things we are talking about, images, and then having these videos that also can be part of the chatbots. Okay. So if I go to little more details in the last 10 minutes, what I'm trying, some terminology you may not be able to appreciate now, but I'm giving you the deck anyway. Maybe once you are dwelling deep into the topic, that time you can refer it. But at this stage, what I mean by this kind of example, if I take the healthcare as a backdrop, just in the interest of time, but otherwise I can pick any example here. I just want to show you AI application, they spread across each and every domain. Okay, if time permits, once I finish it, maybe I will come back in the Q&A session, pick one particular domain, and then I can talk on your favorite domain there. Okay, that may be the last one I can think of, but let me just finish it, taking at least one example of healthcare where I worked for a couple of years. Say there are supervised learning examples we can talk about. Can I have personalized treatment of cancer precision or type 2 diabetes? These are the examples or applications we can solve. Maybe the population health. Okay, can you predict the outbreak of coronavirus or maybe malaria or dengue in a particular region? So can we crowdsource the data and then do it? Those are all possible for the supervised learning. Whereas CNN case, you can classify the chest X-ray, whether it's a COVID positive or negative, or maybe cancerous tissues identification, or in case of LSTM kind of a thing, maybe sequence of parameters of a BP or a diabetic, and can you suggest or can you detect early some kind of a warning? Okay, because you are collecting a lot of data, not just only from or maybe from your watch and maybe your Fitbit applications, right? So those also we can use to give the precision medicine. Then in case of drug discovery, just like we are talking about COVID thing, so those unsupervised learning or GANs are helping us to generate a lot of data, create a lot of scenarios and specific drug validation as well. Okay. Then the reason why the data augmentation is important is, let's say if you talk about even now, if you do 1 lakh tests of the COVID, how many we are getting positive? Maybe 1,000, 2,000 kind of a thing. Or maybe the number is coming down now, but initially it may be, but still maybe even if it is 10,000, 90% is 90% is one class, and then 10% is other class, right? So still we need to, that's not imbalanced class, so we need to augment the data. Okay, so in the reinforcement learning, we need to identify right treatment identification, especially in the COVID thing where we don't know the right treatment, right? So there is a lot of information which people are experimenting, taking the step-by-step thing. Then the reinforcement learning is a good example. Okay, so once I cover the other examples, I'll come back and flash this. So you can ask me which is your favorite application, so I can try to cover those as well. Okay, but the main intention for me, even we can talk an hour only on this particular slide, is AI applications are spread across every domain. It's a matter of time whether it is some applications are or maybe some industries are maybe front running the show compared to the others, but it will touch every industry. Okay, towards the last before I open the forum for you for the discussion, okay, is some project ideas I want to leave you with. We started with very basic essentials, and then I talked about some terminology in terms of you need to be mindful on what kind of type of data you play with. That is one way to divide, because you are not coming from directly from industry or maybe talking to one particular vertical. So for me, it is easy to split the things into the vision part, NLP part, or speech part, so that you can pick it up based on your interest. Okay. In case of image, okay, some kind of a segmentation, autonomous image car, those examples are already there. On top of it, we are talking about image captioning. Okay, if I give an image, can I have the automatic captioning as an example? Can I extract the embedded text? Okay, so embedded text means suppose there is a image which is in the chest X-ray. Maybe embedding some information. I may need to anonymize for the information. Okay. Okay, extract embedded text, and then that means for purpose of anonymization, that means I need to respect the PHR information, right? So what does that mean is I should not reveal any of the, even though I'm making the information public, I should not reveal any of the personal information. So I need to embed the, extract the embedded text. Can it be automatically done using intelligently, because it's not like always at one place, right? Then emojis, we are using in the WhatsApp and all those emojis, just like these simple, they are representative of our feelings and all, right? Can we extract the sentiment out of that? Or in case of text, it's more sarcasm is there compared to the image. Can we do that? Okay. So the standard example I gave is Indigo. Sometimes I go some passenger tweeted to Indigo, thanks Indigo, I landed in Bangalore, my luggage safely went to Mumbai, keep up your services. So without understanding the sarcasm, the bot really replied in the Twitter, yeah, thanks for your cooperation, we'll keep up our service and all. That became a viral. So we need to, after that they are very careful. So I'm talking about few years ago where these many checks are not there. So in that also the other aspect of chatbots we talked about, sentiment analysis is very interesting problem to solve. And a more important point, be it Kannada, Telugu, Tamil, there is a huge amount of funding from government these days on the local languages. Even though a lot of there are interesting areas which you can tie up with other IITs and then see the recent grants in those, both in the text and speech, be it IISc or IIT Hyderabad or IIT Kanpur, there are each of the IITs and IIScs or IISc or IIITs got some good funding, so you can partner and then open for research internships. So they are very good opportunities for you even to play with the local languages. Similarly with the speech. So even with the numerical thing, you can think of volume and result prediction. And as a students or researchers, you have a tremendous job which you can do here in terms of applications, especially for government. There's a lot of data, be it a financial thing or a lot of data is made it available. Even for instance, ISRO, everybody in Bangalore knows, they are collecting huge amount of information. I came to know when I met the previous chairman, I think Karan Kumar. So that time he was telling in Hyderabad and Ahmedabad, they have centers, maybe up to 500 people seating, where with a small MOU from a university or even a small company or any company as well, they can allow the participants to visit the centers and then use their high resolution images, be it for your agricultural analysis or maybe for traffic analysis. It's up to you. And the still data belongs to them, but you can build the models and you can still publish them as well. That's the beauty of that. Okay, you can explore on those aspects. Then what is interesting here is you have huge amount of data, whether it's agricultural related or maybe finance related or different departments, revenue department related at Karnataka level or India level or a sub district level kind of a thing. If you want to predict any of those, there's a huge amount of potential which you can really help. And there are a lot of hackathons also, governments and even other IEEE and other places you will see. You start contributing because that's where the real data is, where you can apply to the society as well. So if I go further on that, in case of video, a lot of analytics you can apply on the video analytics, maybe as a speed control, or you can see how the spread of the virus you are going, or you can talk about fun application where we are talking about now smart TVs, right? So we almost see how much, if I say, let's say, if Alexa is connected to smart TV, just think of it. Your favorite fight sequence from your favorite movie, if you are talking about. So you are just uttering the words and then it is going to the Alexa. Alexa is converting into text that is connected to the smart TV. It is searching in the YouTube. Maybe you are asking some movie and fight sequence. It is going to that particular sequence and playing within fraction of second. So how much of these architecture wise, if you see the sequence diagram as well, how many steps it has taken and how many different models take part in getting that particular thing, right? So even though it's a video thing, what you are finally seeing, it has a lot of other multi-model related aspects. Okay, not just only chatbot aspects, right? Because you need to have annotated data at each and every step. Then robot path planning, that's where the reinforcement learning applications will take really the center stage. Then recommender systems, maybe just to make sure these very popular applications in our regular Flipkart and Amazon, you can apply to your own products. Okay. So these are the applications which you are talking about where it is applicable, and then you can solve as a student as well. And I will show you my blog and some of the interesting, even after all the things people will try to ask me, saying that it's good to see, yes, there are interesting problem where I will get data. Okay, so I written a blog that is on the next one. I'll talk about that. At least 40 business problems spread across text, this and all. I will walk you through that. But before going there, the last gyan from our side is what next? Okay, when you see a lot of maturity on these problem statements in industry and people are really working, what else is still there? So there is a lot of research aspects to go to. Maybe 10 years down the line, we may go to artificial general intelligence. What does that mean is maybe it may compete with human intelligence of the brain, but now it is a way, maybe too far, maybe 10 years down the line. But while building the applications, what is being advocated now is being ethical. How do you ensure the AI models are ethical? How do you make sure you explain the AI model so that you will get the, technically it is good, but how do you convince the regulators? How do you convince the doctors it is really working? How do you build the AI which is responsible? It's not biased to, or it's a fair one. Or how do you make sure the AI is really running in a webcams, or maybe running in a drone, or running in CCTV cameras? Can we really, or maybe in our mobile? Can I build the AI models, or can I run the models in that? So those are the things which people are working on it as an interesting research problems. So as a key takeaway, we started with very basic concepts of AI, ML, and DL. Then where we are really trying to apply in the real world, we left you with some of the real interesting project ideas where you can pick. We may be bombarding with a lot of ideas, but at least even if you pick one or two which is close to your heart, you can make a big difference. So I left you with a lot of references, and this is from my own library, some of the videos which are available. The one which I'm maybe interest to you is these two. So let me just open that for you. These are open blocks. You may need to register if it is not accessing that way. So one is on, this is the one I was talking about. We are talking about so many problem statements, but where I can really get the data and all, right? So I started about talking the same thing. So maybe if you see here, these are the different ways I divided the problem into numerical, categorical, and all. So based on your interest, okay, you are not familiar with the text data or image data or NLP or anything, basic machine learning, deep learning, maybe pick some problem statements from here. Okay, so, and then I given the references of the data as well, where it is applicable, where it is available, kind of a thing. Okay, like that we go to the text level, natural language processing level, some of the code level we talked about. So I'm not walking through the very much too many details, but towards the end I have given at a industry level as well. But maybe being academicians, you may be applicable for initial things, may be more appealing for you. And another blog I will refer it here is let's say top 20 latest research problems in big data and data science. I talked about combining the big data and data science, at least 20 research problems which are ongoing. This may be 5-6 months old blog, which is most software blog these days. So you can find out some of them if you are, maybe you can connect offline as well if I can be of any help to you in that direction. Okay. So with that, in the interest of time, I know I may have skimmed through a lot of these points, but I want to do real justice for the 1 hour I have given so that I can excite you in this field. A lot of things are happening. Okay. Thanks a lot for your attention. I'll take some questions, and as I promised, I'll flash this one. Even if some questions are not there, I can pick it up from your favorite topic from here to explain.
Thank you
Thanks,
very
Ash.
much, sir.
Thank you.
Thank you very much, sir, for your fruitful information about what is AI, needs of AI, and industry application in the real world. I request all the participants, if you have any queries, please type them into the chat window. Otherwise, you can raise your hand so that I can unmute you. You can talk to directly. You can interact with the speaker. I request all the participants, if you have any queries, please type them into the chat window. So by that time, I have one question, sir.
Yeah.
Can you give more insight about this AI robot?
AI robot path planning, is it?
Yes, yes, sir.
Okay, so especially in the robot path planning, a real use case I'll talk about. Let's say in China, when this virus broke out, right? If you see the real applications, what they really used is, because we are talking about non-contactless or maybe contactless kind of activities, right? So they really used the robots to distribute the food in the apartments without person. I mean, where the people are affected, right? So while doing these things in the real field, what really happens is we need to think of some kind of reinforcement learning. The reason is we need to build a robot which can go in the right direction, maybe climbing the steps or walking in the right direction. If it has an obstacle, it needs to go, or obstacle, it needs to go to the, it needs to identify there is an obstacle with the with its eyes and take the different direction, and there is, it knows where it needs to go. So all this to do at every step, it needs to think of some kind of a reinforcement learning. So that's where the real application of reinforcement learning first comes. It may be the top application is some kind of a chess game or AlphaGo game where DeepMind has solved it. And second application is on the robot path planning. So if you're really interested on that, the first you need to master or maybe take some course from NPTEL on the reinforcement learning. Then you should be able, that's one of the real application. For instance, even at IIIT Bangalore, my own professor has even the robotics lab. So maybe in IASC there is something like a cyber physical systems lab as well. So you can see what kind of work they are really doing. Then you can also try to contribute in that.
We can go and meet, sir, in IASC.
Yeah, you can first see in the internet which professor is really sharing your own interest on the robots thing in the cyber physical systems kind of thing. Then you can make a contact and then if it's really in your interesting area.
Thank you very much, sir. We have one question, sir. Can I read out?
I can also read Ashwini, even that one, right? Yeah. Can you please shed some light on NLG, not NLP, and applications? How can one can go ahead there? Some pointers as how to start. Yes, good question. So NLP is actually natural language processing. That's where a lot of development happened. But NLG is natural language generation. One is we usually see even in the machine learning discriminative model and generative model. So generative model means I need to understand maybe the syntax of that particular language or maybe at least where from it is coming, the basic rules of it, and I should be able to do the generation. That means I need to, let's say good examples of NLG are if I give a one paragraph with a keywords, just like think of yourself in a school level, we need to write a story, right? So that means you are generating the language there. That means you need to understand the context and then understand the keywords, what I need to use it, and maybe produce a paragraph out of that. Or even in the chatbot, one type of chatbot is just picking the maybe a knowledge base is there at the end. I'm just asking a query, what is my transaction status? It is just picking it up. It's not doing any real conversation. But the new avatars of the chatbots, when you need to do a conversational AI, you need to do the natural language generation. That means you need to generate on the fly. You need to understand the mood of the customer, and then whether it is trying to maybe more appealing or what kind of pain point he has. Based on that, you should be very careful. You may need to be very careful, just like, okay, or maybe always pleasing, but if the customer thinks that you are making fun of him, then it will come in a reverse way, right? So you should be understanding the mood of the person, maybe sentiment of it, then you need to generate it. So for doing that, where do you need to start is especially you need to understand generative models. I'm just typing there. Generative models you need to understand, and NLP is also part of it as a starting point. The reason is in NLP, a lot of word embeddings are already there. Okay, so before generating the data, you need to understand of a particular language, be it English or our local language, right? You need to understand first, get the grip of that, what kind of embeddings will really suit for us, and then apply that along with the generative models. Then you will go to the NLG. And Stanford University has interesting points. Stanford University plus NL, natural language, I think NLP only. Stanford NLP only, they call it as a group wise, but they have interesting work which can help you out.
Thank you, sir. Rishi, you have any questions? You have raised your hand. There's something is typed, sir. Yeah.
So I can see one question here. So they are saying, I want to pursue my career in data science. Welcome. What to learn first? Okay. So even this is not like deep learning or machine learning, which you need to start first. Even when we are teaching for the people who are of even 20 years experience, the starting point, to be frank, is linear algebra. You need to be strong. Statistics, you need to be statistics. Probability. Okay. So linear algebra, because of all the matrices operations, right? Because being a student, irrespective of what branch you are, you be strong on the math first, and then Python, let's say as a basic Python programming. So these are the prerequisites to start with. Then go with the ML. Okay, understanding whether you are doing the course in your thing or maybe NPTEL has a lot of free courses as well. After that, ANN and DL, maybe that is a common thing. The difference between artificial neural networks and DL, in simple words, deep learning means it's also based on neural networks. If the neural networks, the chain of that neural networks, right? At least if the hidden layers are more than 2, then we are calling it as a deep learning. So in a simple words, even deep learning covers the basics of neural networks. Maybe fuzzy systems and all is a little different topic, but in the path of our data science, after you got through this math and Python programming, then ML, then I will say DL. After that, you can go into the reinforcement, all the new advances you can think of.
Thank you, sir. There is one more question in the Q&A, sir.
Okay. Have I missed out that?
Q&A window.
Okay, Q&A window. I'm seeing only the chart window. Can you read out for me?
Sir, can you suggest I should go for R or Python for open source data set for AI application in wireless communication? Also, have you came across a platform such as H2O? What is your feedback, sir?
Okay, so there are 2-3 questions. So H2O, yes, I used it. That is compared to H2O in the open source, even they have enterprise and open source edition. So let me start with the first question. So whether you want R or Python, if you are doing a statistical analysis, R is still unbeatable, right? So Python is good for a machine learning and deep learning. But if your analysis is mainly turning around the statistical analysis, you need to start with R. But if you need to start with only one, then my recommendation is Python, so that you can apply that Python learning even for machine learning and deep learning. That's answer number one. Second thing, you are asking any data set for wireless communication. I need to understand a little more in terms of what kind of wireless communication is 2G, 3G, 4G, 5G, what kind of things you are expecting. I need to understand. I'll come back to that to get your input. But for the third question, now third part of the question, H2O, there are a lot of open source libraries. Okay, so what H2O is meant for, there are some machine learning algorithms, there are some DL. If you ask me in the industry, is it the standard, the de facto standard to use it? Need not be. So in case of machine learning, scikit-learn or sklearn kind of packages are good for machine learning. And then Keras and TensorFlow, I'm just typing as well, or PyTorch. These are the ruling the things for the deep learning thing. Okay, so H2O has some specific packages which make our life simple. So if there is some free package from H2O which people are using it, especially from the plug and play kind of a mode, you can still use it. I'm not saying you can't use it, but basic thing you can start with is first sklearn for the machine learning and Keras plus TensorFlow maybe for the deep learning. After that, you can think of other packages.
Thank you, sir.
The wireless communication part, you should let me know what exactly you mean. Based on that, I can try to ping you.
I request participant, any questions are there, please type them into the chat window or Q&A window. I'm not finding any questions, sir. So
Okay.
I thank you once again, Dr. Sunil, sir, for accepting our invitation in your busy schedules to share a thought on AI. And also, I sincerely thank you all participants. Thank you on and on. Thank you, sir.
Thank you. Thank you and happy learning and be safe.